Hello folks, here will be our video for section 510 on quadrilaterals, medians, and bisectors. And this is really just a section with a lot of definitions. Nothing really in terms of new theorems, but there are some definitions so that we're all on the same page and using certain words. And then if those words appear in problems later on, you know what they mean. So our first definition here is of a quadrilateral. And I think you already know what a quadrilateral is. It's a four-sided figure. So we're just going to spell that out in detail. I wouldn't really stress over the details of this. If you think you know what a quadrilateral is, you're probably right. But the idea is we're going to let A, B, C, and D be four coplanar points, and no three of them are collinear. All right, so maybe I have an example like this. So you'll notice that no three of these points are on the same line, but they're all in the same plane. And if I look at the segments, the segment AB, the segment BC, the segment CD, and the segment DA, they only intersect at those 4 points, A, B, C, and D. They don't crisscross each other in the middle. So here up on the corner, I can't say 1, 2, 3, 4 sides, that's a quadrilateral. That doesn't count. And I can't say, oh, I have a quadrilateral where 3 of my points are collinear and it looks like this. That's really just a triangle. And I can't have a four-sided figure where the 4 points aren't all on the same plane. But assuming that I rule out those weird cases, this would be an example of a quadrilateral. If I take the union of the 4 segments, that's a quadrilateral. So the purple stuff is the quadrilateral. Technically, this stuff in the middle we would call the interior of the quadrilateral, but it's not actually the quadrilateral. The segments are called the sides. The points are called the vertices. The angles are called the angles. All of that's pretty clear. Segment AC or segment BD would be called a diagonal. So diagonal doesn't necessarily refer to its orientation. Here the segment AC looks pretty horizontal and not diagonal. Diagonals are just segments that go across a quadrilateral between opposite things. The perimeter is the sum of the lengths of the sides, we know that. And the way we can name this is we write a box, so it's not necessarily a square. And then we write A, B, C, D. Now, this order matters. We're saying we go around A to B to C to D. We have some flexibility. Another way you could have named this, for example, is B, A, D, C. I go from B to A to D to C. But you can't just randomly write letters. So it would be wrong to say, oh, it's C, A, D, B. Because that's the wrong order. As I go around the edge of this quadrilateral, the vertices are not in the order C, A, D, B. So that's wrong. But there are a lot of correct ways to put this. So basically just pick which point you want to say first, and then pick an order, and then list them in order. But just like we wrote the triangle symbol for a triangle, we'll write this little box for a quadrilateral. And even though that box looks perfectly square, we're not saying it means square, it just means quadrilateral. So now just a few definitions that should relate to things you already know. If I have a quadrilateral with 4 right angles, I'm going to intentionally draw it at a slant. If I have a quadrilateral with 4 right angles, this is called a rectangle. So the definition has to do with the right angles. Now, you probably believe in a rectangle that opposite sides are congruent, but that is not part of the definition. It's something we'll prove later on. The definition of a rectangle is just a quadrilateral with 4 right angles. A quadrilateral with 4 right angles and 4 congruent sides. So it's a rectangle because it has, oops, let's make that a little bit better. It's a rectangle because it has 4 right angles, but in addition it has 4 congruent sides. that's a square. So we'll just note that given these definitions, a square is a kind of rectangle. When you were a little kid, you were probably taught that square and rectangle were different shapes. Actually, a square is just a very specific type of rectangle. So we had some vocabulary here related to quadrilaterals. Most of this makes sense in context. Diagonal might feel a little bit new, but I think you'll get used to that. Rectangle and square are certainly words you know, but make sure you know the actual definition. You probably know a lot of things about rectangles, but make sure you understand that the definition emphasizes the right angles. And we're going to add just a few more definitions related to triangles. So here, a median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So here I'm going to draw a triangle. Here's triangle ABC. And maybe over here I have the midpoint of segment AC. Midpoint means that those two distances are equal. So if I draw a segment from one vertex to the midpoint of the opposite side, that segment is called a median. So segment BN is a median of triangle ABC. And I say it's a median rather than the median because there are three of them. If I take a triangle, any triangle would have three medians. Here, if I go from this vertex to the midpoint of the opposite side, that thing in green is a median. Or maybe I go from this vertex to the midpoint of the opposite side. The thing in pink is a median. Or maybe I go from this vertex to the midpoint of the opposite side. So there are three medians in any triangle. What you might notice is they all go through the same point. That's a theorem that maybe we'll prove later. I don't know if we'll get to it. But it is true that if you draw all three of them, they intersect in the same point. But please know this word. Don't think, oh, it has kind of something sort of to do with middles. That's not good enough. You need to understand that a median is a kind of segment that goes from the vertex of a triangle to the midpoint of the opposite side. Now, another definition is angle bisector of a triangle. So in the context of a triangle, sometimes we will use the term angle bisector in a slightly different way. So I'm going to draw a triangle, like so. So here's triangle ABC. So here's what I'm going to do. Let's think about the ray that bisects one of the angles of this triangle. So maybe something like, maybe something like so. Right about like that looks good. So this thing in blue is the ray bisecting angle BAC. In the context of a triangle, we could say that a segment is an angle bisector if it first lies on this ray and has as its endpoints one vertex of the triangle and a point on the opposite side. So let's call this X. So when we're talking about a triangle, we would be able to say that segment AX is an angle bisector. And it's sort of implied of the triangle. So formally speaking, when we talk about angle bisectors, they're rays. But if we're talking about an angle bisector in the segment of, in the context of a triangle, it is okay to talk about just a segment being a bisector. And I do want to warn you, angle bisectors and medians, do not get them confused. Both of them do some sort of bisection. In a median, we have this segment that's bisecting this side. Segment AC is getting bisected because M is the midpoint. Over here, we're bisecting the angle. And let me just give you a warning. Generally speaking, medians and angle bisectors are different segments. I'll draw a picture to make that pretty clear. So in this example, for segment YZ, it looks like our midpoint is somewhere around here. So segment XM is a median. But in terms of bisecting the angle, if I want to bisect this angle, it looks like it would be something like, more like so. This angle and this angle are congruent. Let's call this N. Segment XN is an angle bisector. Both of them create a kind of symmetry, but they create different symmetries. In one case, we'll have congruent segments on either side. In the other case, we'll have congruent angles on either side. Make sure you are crystal clear on the differences between these two. But I will just sort of plant in your head something that might be worth thinking about is, when are they the same? Okay, so really just some new vocabulary, make sure you know it. And that is it for this video.